Bismillahirrahmanirrahim. Dear student, Assalamu alaikum. Our today topic is relation between the roots and coefficients of a quadratic equation. So, what is the relation? First of all, we will prove the two results from that relation. If we solve a quadratic equation, we get that is standard form of quadratic equation. If we solve any quadratic equation, we get two roots. So general roots are minus b plus minus square root of b square minus 4ac divided by 2a. There are two roots, so we name them. Let one root is equal to alpha, that is alpha is equal to minus b plus square root of b square minus 4ac by 2a, and second root beta is equal to minus b minus square root of b square minus 4ac by 2a. So we name them just to, instead of writing these two roots again and again, we name them alpha and beta. So first result, that is sum of the root. So sum of the root means alpha plus beta. So adding these two roots, first root plus second root. So by adding these two, 2a is the LCM. So first root plus second root. Simplifying the brackets, we get minus b plus square root of b square minus 4ac, plus minus become minus, and plus minus again minus square root of b square minus 4ac. So here plus square root of b square minus 4ac and minus square root of b square minus 4ac cancel each other. Minus b become minus 2b. So minus 2b divided by 2a. 2 cancel with 2. We get sum of the root alpha plus beta is equal to minus b by a. So minus b by a mean coefficient of x in the quadratic equation divided by coefficient of x square. So thus we can write simply direct by solving the quadratic equation, or without solving the quadratic equation we can find the sum and its product. So the sum of the roots will be minus coefficient of x divided by coefficient of x square. Similarly, product of the root mean product of these two given substituted roots, that is alpha into beta. First root multiplied by second root. So look at this. First root minus b plus square root of b square minus 4ac, and in second factor minus b minus square root of b square minus 4ac. So we get a form of the formula a plus b, a minus b, mean a square minus b square. So using that formula, a square minus b square form, minus b square in square of the first term minus square of the second term, square root of b square minus 4ac square, divide by 2a become 2a square. Now simplifying the square, minus b square become plus b square minus square root cancel, we get minus into b square minus 4ac. Again simplifying this bracket, we get b square minus b square, and minus become positive, minus 4ac divided by 4a square, we can write 4a into a. Now b square minus b square cancel, we get 4ac divided by 4a into a, or simply 4a cancel. So we get c by a. C by a mean that is product of the root, that is equal to coefficient constant term divided by coefficient of x square. Thus we get two results. First, sum of the root is minus b by a, minus coefficient of x divided by coefficient of x square, and product of the root constant term divided by coefficient of x square. So without solving a quadratic equation, we put the values of a, b, c and get the sum of the root and product of the root. So for example number 10, part first, Without solving, find the sum and product of the root of this quadratic equation. So first of all, comparing this quadratic equation with the standard form of quadratic equation to get the value of a, b, c. So here a is equal to 2, coefficient of x square, b minus 3, and c is equal to minus 4. Now sum of the root denoted by s is equal to minus b by a. Minus b by a minus into value of b is minus 3 divided by 2. Minus minus become plus, plus 3 divided by 2. So sum of the root is 3 by 2. And product of the root p is equal to denoted by p, that is c by a. We have already proved that. C by a means constant term value of c, that is minus 4 divided by 2a. So 2 to the 4 we get minus 2. Thus without solving any quadratic equation we can find the sum and product of its roots. That is the use of these two results and the application of roots, relation between roots and coefficients. Now come to exercise. Question 1, part first. Without solving equation, find the sum and product of the roots of this quadratic equation. So first of all, comparing 4x square minus 4x minus 3 equal to 0 with the quadratic equation, standard form of quadratic equation. We get a is equal to 4, b minus 4, c minus 3. So sum of the square by direct formula, sum of the square alpha plus beta is equal to minus b by a, putting the value of a and b. That is, sum of the root is equal to minus value of b is minus 4 divided by 4 value of a is equal to minus into minus become positive 4 by 4. 4 cancel with 4 is equal to 1. That sum of the root is equal to 1. Similarly, product of the root alpha beta is equal to c by a. C by a, putting the value of c and a. So value of c is minus 3, value of a is 4. So product of the root is minus 3 by 4. Thus without solving this quadratic equation, we can find the sum and products of its roots. The sum method, question 1, part 3. Without solving equation, find the sum and product of the quadratic equation 3x square plus 2x minus 5 equal to 0. So comparing the given quadratic equation with standard form of quadratic equation, we have a is equal to 3, b 2 and c minus 5. Thus sum of the root alpha plus beta is equal to minus b by a, putting the value of a and b. We get sum of the root minus value of b is 2 divided by 3 minus 2 by 3. Similarly, product of the root alpha beta c by a, putting the value of c and a, we get product of root is equal to minus 5 by 3. Value of c is minus 5 and value of a is 3 from these three values. Thus we get sum of the root and product of the root without solving a quadratic equation. Now come to question 2. Question 2, find the value of k if sum of the roots of this equation 2x square plus kx plus 6 is equal to product of the root. So another use of these two results, sum of the root and product of the root. Here we have to find the value of k, which is unknown. By using the two results, comparing this given quadratic equation with the standard form of quadratic equation, we get a is equal to 2, b is equal to k and c is equal to 6. Well, we get value of a, b and c, three constants. Thus according to the given condition is product of the root of this quadratic equation is equal to sum of the roots. So sum of the roots is equal to product of the root, that is alpha plus beta is equal to alpha into beta. Now general value of alpha plus beta, that is minus b by a, and product of the root is equal to c by a. A is common, So we can cancel a directly, r multiplying both sides by a. So multiplying both sides by a, we get minus b is equal to c. Now in this condition, minus b is equal to c, we put the value of b and c. B is equal to k, that is substituting the value of b and c, minus k is equal to 6. Rk is equal to 6. Thus we get the value of k by using direct two results, sum of the root and product of the root. Second method of this question is sum of the root. First of all, find sum of the root, then product of the root, and then writing them in the form sum of the root is equal to product of the root. Again we will get the same result, the same value of k is equal to minus 6. So this is the easiest way. According to condition, sum of the root is equal to product of the root. Put their value, simplify it, and substituting the value of a, b, c, we get the unknown k. Next comes to question 3. Find the value of k. Again the same unknown. If the sum of square of the roots of x square minus 5kx plus 6k square is equal to 0 is equal to 13. Only condition is different. So sum of the square of the root mean if we take alpha and beta are the two roots of this quadratic equation, then sum of the square of the root become alpha square plus beta square is equal to 13. So that condition become alpha square plus beta square is equal to 13. So to find or using this condition, first of all we are going to find the value of sum of the root and product of the root. So for sum and product, comparing the given quadratic equation with the standard form of quadratic equation ax square plus b plus c equal to 0, we get a is equal to 1, b minus 5k and c plus 6k square. So sum of the root is equal to, that is alpha plus beta is equal to minus b by a, direct formula. So substituting the values of b and a, minus into value of b is minus 5k, so minus minus become positive. 5k over 1 is equal to 5k. We get sum of the root 5k. Similarly, product of the root, that is c by a. So putting the value of a and c, product of the root is equal to value of c is 6k square and value of a is, that is 1. So that is equal to 6k square. Now according to condition, given condition, sum of the square of the root is equal to 13. So we write alpha square plus beta square is equal to 13. Now we will find the value of this expression using these two results, sum of the root, product of the root. So for this we have a formula. For example, a square plus b square plus 2ab is equal to a plus b whole square. So changing in the square form to change this result into complete square, we write this as alpha square plus beta square plus 2 alpha beta to get alpha plus beta, that is a plus b square. So if we are adding some term plus 2 alpha beta, subtract that term minus 2 alpha beta, again they will cancel, we get the same alpha square beta square. So using this result to make the complete square from the first three terms, so combining the first three terms, alpha square plus beta square plus 2 alpha beta, this become alpha plus beta whole square minus 2 alpha beta is equal to 13. Now we get the form in which alpha plus beta, we have the value, and alpha beta product, we have the value of product. So putting the value of alpha plus beta and alpha beta in this equation, putting the values, we get alpha plus beta 5k whole square minus 2 into alpha beta product is 6k square is equal to 13. So that become 5k square become 25k square minus 2 6 are 12k square is equal to 13. 25 minus 12. 13k square is equal to 13. Dividing both sides by 13, we get k square is equal to 1. Taking square root on both sides, we get k is equal to plus minus 1. Thus we get the value of unknown, k is equal to plus minus 1 using these results. So the main question is this one: how we can change or simplify the given condition into sum and product. So we have some formula, basic formula, which we have already proved in previous classes. Using that formulas, we can transform any relation into sum and product form. So we, first of all, the main point is this one: transform this relation into sum and product. So by adding and subtracting, we get a whole square form and product form. So that is the main question. Then by putting the values, we get the value of unknown k. Next, the same method, question 4. For what value of k the roots of the equation x square minus 5x plus k equal to 0 differ by unity? Only condition is different. So first of all, differ by unity mean if we take one root alpha, second beta, then this mean their difference in alpha minus beta is equal to 1. Differ by unity. Differ by 2, so this mean alpha minus beta is equal to 2. Differ by 3. Question 5, the same relation is given. The roots of the given equation differ by 3, so we will write alpha minus beta is equal to 3. That is one method, the simplest one. Second method of this question is the roots of the value the k such that the roots of the equation differ by unity, mean if we take one root alpha, we will take the second root alpha plus 1. This means there should be difference between two roots. There should be a difference of 1 only. If we take one root alpha, second will be alpha plus beta. Or if we take one root alpha, second we can take alpha minus 1. It should be less than or greater than 1. That is, if one root is alpha, second root is greater than 1 greater than the first one, or 1 less than the first one. So that is another method. We take the first method, which is the simplest form. So first of all, to find the value of sum of the root and product of the root, comparing the given quadratic equation with the standard form of quadratic equation, we get a is equal to 1, b minus 5, c is equal to k. Now sum of the root alpha plus beta minus b by a, putting the values we get 5, and product of the root alpha beta c by a, putting the values we get k. Now using these two results, according to the given condition, the roots of the given quadratic equation differ by unity, mean alpha minus beta is equal to 1. If alpha beta are the roots, therefore using this formula, now we have three terms: alpha plus beta, alpha minus beta, and alpha beta. So all the three will be used in this form of formula. That is, alpha plus beta square minus alpha minus beta square is equal to 4 alpha beta. We have already proved in previous classes that a plus b square minus a minus b square is equal to 4ab. So that's the same form. Here, instead of writing a and b, we write alpha beta. So look at the formula. We have product, sum, and difference. Now putting the values of these three known values. So 4 into alpha beta product is equal to k is equal to alpha plus beta, that is 5. 5 square minus alpha minus beta 1 by condition 1 square. Simplifying these, 4k is equal to 25 minus 1. 25 minus 1, 24. Divide both sides by 4. Divide this equation by 4. So k is equal to 24 by 4, or 4 6 are 24. We get k is equal to 6. Thus the value of unknown is obtained. Next comes to question 6. If alpha beta be the roots of x square minus 5x plus k equal to 0, find k such that 3 alpha plus 2 beta is equal to 12. Another condition. If such condition, that is one equation is given in respect of alpha beta. So first of all, we have two methods, that is alpha, we find alpha plus beta. So one condition is 3 alpha plus 2 beta is equal to 12, and we find alpha plus beta. Now solving these two questions, the two equations, by solving these two we will get the value of alpha and beta. But the second method is the simplest one. Let it do by solve it by second method. So first of all, sum of the root and product of the root. In the same way, comparing given quadratic equation with the standard form, we get a is equal to 1, b minus 5, c is equal to k. Thus alpha plus beta, that is sum of the root, minus b by a. By putting value of a and b, we get 5. And product of the root, c by a, putting the value, we get k. Sum of the root 5, product of the root k, according to the given condition, which is given 3 alpha plus 2 beta is equal to 12. We can write 3 alpha is alpha plus 2 alpha plus 2 beta is equal to 12, because there must be some common. So we take common from these two terms. Alpha plus 2 common, we get alpha plus beta is equal to 12. Now putting the value of alpha plus beta, we have alpha plus 2 into sum of the root 5 is equal to 12. Simplifying, alpha plus 2 5 are 10 is equal to 12, or alpha is equal to 12 minus 10, transforming 10 to right hand side. Alpha is equal to 2. We get one value, alpha is equal to 2. Put this value of alpha in the given equation, alpha plus beta or alpha beta. In any one you can put them. So in second equation, in first equation, alpha plus beta is equal to 5. Put alpha is equal to 2. So we get 2 plus beta is equal to 5. Or beta is equal to 5 minus 2. Beta is equal to 3. Thus we get both the values, alpha 2, beta 3. Now using that, because we have to find the value of k, the relation of product alpha beta is equal to k, so putting the value of alpha and beta in this relation, we have alpha beta is equal to k, alpha is 2, beta is 3, 2 into 3 is equal to k, or 2 3 is 6, thus we get the value of k is equal to 6, which was unknown. Next question 7. Find the value of m and n if both sum and product of the roots of the quadratic equation mx square minus 3x minus n is equal to 0 are equal to 3 by 5. The given condition is sum of this root and product of this root both are equal to 3 by 5. So using this condition, first of all, comparing this given quadratic equation with the standard form, we get value of a is equal to m, value of b is equal to minus 3, value of c is equal to minus n. So sum of the root, it is given both the sum and product are equal to 3 by 5. So this means first condition, sum of the root alpha plus beta is equal to 3 by 5. It is given. So sum of the root is equal to minus b by a is equal to 3 by 5. Putting the value of a and b, minus value of b is minus 3 by m, that is plus 3 by m is equal to 3 by 5. So by cross multiplication, that become 3m is equal to 15. Or dividing both sides by 3, we get the value of m is equal to 5. Next, in the given condition, product of the root is equal to 3 by 5. So this means alpha beta is equal to 3 by 5. Again, Product of the root is equal to c by a is equal to 3 by 5. Putting the value of a and c, that is value of c is minus n, value of a is m is equal to 3 by 5. Again by cross multiplication or by putting value of m, because that is noun. So value of m we have 5. So put the value of m in this relation. Minus n by 5 is equal to 3 by 5. Again directly we can cancel 5 or multiply both sides by 5. So we get minus n is equal to 3 or n is equal to minus 3. Thus two values of two unknown, n is equal to minus 3 and m is equal to 5 we get. So by solving, by applying the condition and using the two results, sum of the root, product of the root, without solving a quadratic equation, we can find the unknown in the given quadratic equation. That is the use of the two results. So that is the end of our today lesson. Thank you so much. Allah Hafiz.